Welcome to the third lesson of the rate and extent of chemical change topic. In this topic, the key question is 1. What are catalysts? Key terms that you need to be familiar with: catalysts. In today's lesson, we will talk about catalysts. Catalysts are chemical substances that increase the rate of chemical reactions. Task. Now please pause the video and think about how a catalyst affects the reaction rate. Hint: the example on the image above is a catalytic converter used in cars. Extension. How can you describe the effect of a catalyst energetically? A catalyst always increases the speed of the actual chemical reaction. The catalyst takes part in the reaction mechanism, but it forms back and no catalyst is being lost during the reaction process. One good example is the catalytic converter in cars that helps combusting the fuel. A catalyst opens an alternative reaction path for which the activation energy is lower than the original activation energy. This means that the reaction will need less energy input. Therefore, reactions might not need a high temperature. An example is the heterogeneous catalysis of hydrogen combustion on a platinum surface where hydrogen is being combusted even at room temperature. This idea is used in hydrogen-based fuel cells. The energetic change is demonstrated in the image below. When a catalyst is applied, the structure of the activation complex, transition state, is different to the original, no catalyst present, structure, and it will also be less energetic. Therefore, the new transition state can be more easily converted into products. Task. Now please pause the video and think about possible applications of catalysts. Hint: remember, catalysts open an alternative reaction route and with this lower the activation energy. Extension. How could the idea of catalysis be applied for biology? One example has already been mentioned: catalytic converters in cars. However, catalysts are very useful in any industrial processes that otherwise would require extreme conditions, high pressure or high temperature. For example, ammonia production is made with the application of a catalyst. On the other hand, most biochemical reactions require the presence of biocatalysts. These are called enzymes. Enzymes are very important as they make biochemical processes feasible at room temperature and atmospheric pressure. Otherwise, no living organisms could exist. Enzymes are always specialized protein molecules, which are specific to certain reactions only.